face from it. To wrap it up, obviously, getting connectivity, getting internet connectivity, which is one of our goals to all of these places, will require a lot of effort. Every country will be different. We believe that wireless technologies will play a big role in bringing connectivity to a lot of places. We have, as one of our partners, CES Global, which is the largest satellite operator right now in the world. And because in remote areas, satellites, for example, will play a very important role. But we are not trying to endorse one technology over the other. Every country has its peculiarities, and we'll try to work with everything that will be available. It's a sandbox approach, but it's not the Java sandbox approach. It's more of a kernel-based, process-based sandbox approach. So we believe in that, and we take it very seriously. We'll be able to guarantee that our laptop will never be used in that respect. I don't think so. But I think we are in a much better shape than the commercial products out there.
Will there be access to the distribution for people who just want to play around with it? Or is
Oh yeah, it's already. I mean, everything is completely open. And the few things that we don't have open on the laptop right now, we will open eventually.
Yeah, well, yeah, we could just hold it for you while you look at it.
I've got such a dirty screen, it doesn't make a difference.
This is outdoor. Yeah, outdoor.
Do you want me to hold them?
Yeah, let's hold them the other way.
Let's
hold them this way.
Okay, perfect.
Let's this way. Kind of stand the way I'm standing. So you can see. Can you see the difference? Wow. We actually took a.
There's a picture of, is it you and Mary Lou doing this? I saw that.
On my dad's rooftop. My dad's has a rooftop, and so it's a big difference in reflectivity.
So this is 0.2 watts it's consuming right now.
Yeah, this is on. Is this in reflective mode?
Yeah,
right now?
it should be in down to the lowest. Let me make sure. I'm sorry. Yeah, it's down.
So there's several settings of backlight.
Yeah.
Yes.
So you can shift the backlight off.
And I went ahead and opened up that application.
Okay.
So you can see.
Oh. This is totally viewable.
Mm-hmm.
Yeah, it's very. Right. It's a significant difference.
And this is one of the memory matching games that's included in the basic bundle. It's one of the applications. It's very similar to a matching game you'd play when you were a child, but it also has sound as well.
Yeah,
that's cool.
Yeah.
Yeah. So it's not only even if you were not aware of what the picture was, a sound is played with it as well. So you not only
about learning, and so you get a different tack from it rather than somebody who's caring about, I don't know, personal productivity.
Right, exactly. There's someone who's worried about running a business.
Right.
Per se.
You don't. The other way.
I'm going. It just went. Oops.
It's okay. Oops.
That's one of the problems with it. Oh, I can plug that right back in.
But this is from the production bunch, huh?
Yes, this is from the first round, beta 1, with alpha software on it.
So this is our attempt to try to get it 80%, 90% of the way, and so we've got a lot of
Those currently aren't operational.
But we've got a lot of the softwares weren't written when this came out.
Right.
Could you try close it and hold it like with the handle? Alright.
It also has these little holes in it, so if the children put a strap through it, they can carry it over their shoulder and swing it over their shoulder.
Do you have one of the yo-yos here?
No, that's he. I'm not.
As an audio player, there's a great demo with C-Sound that you can see.
Thank you very much.
As an audio player, it has no problem. You can do anything. I mean, you can synthesize 4 instruments. The keyboard manufacturer completely screwed up the keyboard. Quanta completely screwed up mouse buttons. They are recessed, so you can really push them. And Alps completely screwed up the trackpad.
So things are going smooth.
Everything else works.
Okay. That's what beta is for.
Everything else works. But that's why we do the beta. You know what? We are not in the money, we are not a for-profit company, so we can afford to send the machines out. I mean, it's not we're going to lose our sales or AMD is going to cut our support salary. Oh, you didn't do it right the first time. You are off the window. We can afford to do these things, and it's very interesting the fact that we sent this laptop out and we got like several hundred of errata for people. If we had done in-house testing, like a focus group or control testing or anything like that, we would have gotten back nothing. So, but we can afford to do that. I mean, it's open development. Everything is pretty much in the open. I mean, we can't really give out the display design yet completely because CDN has somehow benefit from that.
Oh, okay. What's the story going to be for email?
There is a chat program that works in the mess right now there. We will try to build something that's upper.
Okay.
So
there you're actually closing some software?
Right now I'm in the screen that actually,
yeah?
It's the task manager essentially. This is the task manager.
Right.
So you see yourself and you see the applications, the activities that you're running around you. The reason that we moved away from the overlapping windows and we have this single window with a control frame around it is the fact that most new users, computer users, seem to be very confused by overlapping windows. So we wanted something that's very simple, very clean in the look, and very easy to put on a 7.5-inch display.
So you don't have to find the cross and close windows and stuff?
Exactly.
Yeah?
So this is the main task manager. So from here you can actually switch applications.
Are there also shortcuts on the keyboard to do those
Yes, if
things?
you want, you can put shortcuts in the keyboard. Yes.
Yeah?
So this is the memory game, for example.
But would it be possible to also have the traditional interface if people want?
If you want, yes. It's a Linux machine. You can load the traditional interface. If you go around, like Analog Devices has a demo in their booth, in their actually private meeting rooms. With,
Analog Devices
is making the codec, the audio codec on this laptop.
Right.
So they have an audio application running. That audio application uses floating normal windows. So actually, we have a classic environment here. We call it X Windows Classic. So you click on an icon and you get a normal floating window manager if you want. So if you want to run applications that are unchanged. Yes. They have not been modified to work in this single window environment. You can run a classic window manager.
It's like a normal a normal Fedora distribution?
Yes.
But it's not you'd have to use, for example, the memory stick, the SD card to launch that, or you can just maybe have it there?
No, you can put it in the flash. You can put it in the flash. You can load it in the flash. We would recommend, a lot of people are doing that, so since they want to use classic Linux applications, we would recommend that you use like a simple window manager. So you don't have to load all the services.
Is it GNOME? What's it called?
GNOME is, we use the GNOME toolkit essentially to paint on the screen. But we don't use the full Windows, the full windowing environment that Fedora comes up with, GNOME plus Metacity, Window Manager, etc. We use something which is
because is this interface working better on this hardware than a Windows?
It's simpler.
Interface?
It's different. Hopefully, it will work better. I mean, time will only tell if it works better or not. We think it is. We designed it for kids. We designed it to be much easier for kids to get familiar with. And remember, these machines are going to users that don't have pre-existing experience.
All right. Yeah.
So it's not like you and me. I mean, you and me see this, and said, "Oh, this
Yeah.
looks weird. What do I do with it?"
Yeah, of course. We've been
because
living
we are
with
used to the
Windows for 10,
classical,
15, 20
yes,
years. Yeah.
windowing environment. This
Yeah.
goes to people who start with a blank slate. So
Yeah. It's a
you
little
have
bit like
to-
the Wii, no? It's going to people who are not used to the interface.
They're not used to
Yeah?
computers, period.
Yeah.
So you have to make sure that's simple. So one of the main confusing points
Yeah.
of overlapping windows is the fact that people get lost. They don't know how to bring things on in front. They don't know how to
Yeah.
bring things in the background. And this is much easier.
Yeah.
You just go to the switcher here, and you switch between applications. This is Abbey Word, by the way.
All right.
This
Abbey
is-
Word.
Yeah.
This is a chat program?
This is the chat program. This is the word processor that we are using, which is Abbey Word.
And this button you just hit, for example, what?
This button, under normal circumstances,
Yeah.
brings or makes the frame disappear.
Makes the frame disappear.
The control frame disappear. So if you want to be full screen, because right now you are missing,
So this button also make it appear,
it
maybe?
makes the frame go
Appear,
away.
disappear.
Yeah.
And-
The way that you bring the frame back and forth normally is you just move your cursor
Yeah.
to the edge of the screen and the frame comes back.
So could you just introduce
Sure.
yourself, like what you're doing with the OLPC?
Yeah. Let me reboot this because
All right, there's a reboot. Yeah.
it reboots like a Linux machine, and
Yeah.
this machine, this specific prototype takes much longer than the
Yeah.
normal machine
Will do.
because the NAND controller, the flash controller on this machine, it's a prototype
Yeah.
built on an FPGA. It doesn't have the ASIC, the real
Right.
ASIC, which is going to be in the machines that we are producing starting next month.
How did you reboot it? Did you push a button or?
You go to there is an X button.
Is it
actually,
this one
there-
or no?
No,
No?
There is an X button on the user interface,
Oh, yeah.
which you go and.
All right. So could you explain? Just introduce.
Yeah, my name is Michail Bletsas. I'm
Yeah.
OLPC's Chief Connectivity Officer. In that capacity, I'm responsible for the laptop being connected all
Connected.
the time, either to other laptops or to the internet.
All right. So you work with the mesh system?
Yes, I specified that.
In- Yeah.
Designed a lot of the aspects of the
All right.
mesh net, which look funny, but they actually double the range of the
yeah.
laptop. Actually, we had some reports that people in the outback in Australia were able to get a connection to an access point from a kilometer away.
A kilometer.
Yeah.
All right.
Because these antennas are like
Yeah.
3 or 4 dB
Yeah.
above
But-
in gain what normal laptops have,
Oh, yeah?
the normal embedded
So the Wi-Fi
antennas.
range is much better than my laptop.
Yes, the
Yeah?
Wi-Fi range is much better in this laptop than normal laptops. Basically, we use a good radio, but also because our antennas are about 3 to 4
Yeah.
dB.
So this is
This is Linux booting with all
Yeah.
the debugging messages
yeah.
that you are going to see. The software is in very rough form.
Yeah.
People can download it from the wiki and play it, put it on an emulator. Right now we are concentrating on getting the fundamentals right. And then we will worry more about performance
Yeah.
an emerging standard, so it's always good to follow standards, but it's also because since it's a layer 2 technology, so it operates at the Ethernet level, at the frame level, it allows for a very clean separation between the mesh code and the rest of the networking stack. And that's very crucial for the laptop because you want the mesh code to run independently of the rest of the network stack. So you can actually suspend the laptop and still keep the radio forwarding frames for other laptops. So
you were talking about you were talking about a processor inside the chip,
yes.
I mean the Wi-Fi chip.
Yes. So the wireless radio on this laptop is a it uses a system on a chip type of radio, which means that it has its own processor, core, and memory. So pieces of the networking stack are running natively on the Wi-Fi radio, not on the main CPU. That allows you to run the mesh even when the main CPU is suspended.
All right. So would you see, for example, this button, but if the user doesn't want to have it running, he can also shut it off?
Yes.
Yeah?
Yes.
And can it wake up if there's a call coming in, for example?
Yes, it wakes up if there is a frame that's addressed to the specific laptop, then it wakes up the CPU to deal with it.
All right.
But it's a frame that's destined for other laptops, it just keeps forwarding it.
So for example, Skype, if there's a Skype call coming, a voice over IP call,
anything that sends a packet that's addressed to this machine. Obviously, that's something that you can set up. You can say wake up or don't wake up.
Oh, yeah.
If you have traffic.
So it's like a phone, a mobile phone.
Yeah.
Yeah. On a Wi-Fi.
Pretty much.
Yeah.
Pretty much. I mean, we use the wireless chip that we are using.
Yeah.
It was actually designed for a mobile phone type of application, low power, functional multiprocessing type of application. So that's the interface that I saw. If you actually
now it's totally booted up,
move the cursor
to the top,
to the top or to the edge of the screen, you get the control frame, and this is the main screen. So if you want,
right? Because on the market today, there isn't a Wi-Fi phone that just can sleep somehow and stay connected to Wi-Fi. That's not possible. For now, you have to turn it on, and then you can receive Skype calls, no? And that consumes a lot of power.
Exactly. So with a laptop, we are able to do a lot of power savings, just because our radio processes Wi-Fi frames using 350 milliwatts of electricity. Because, again, the radio is a smart radio. It has its own core and memory and can do all the processing locally. If you had a normal Wi-Fi radio, in order to process any kind of frame, you have to have the CPU.
The whole computer running all the time.
And that consumes many watts, several watts of electricity.
All right.
So
there it will run at least, how long will it run without the...
Just frame forwarding for the mesh, we're talking about between 1 and 2 days, depending on the condition of your battery.
Does it also depend on the amount of data?
Not too much, actually. It doesn't depend too much on the amount of data. It does depend on the amount of data, but it turns out that that's just keeping the chip running.
Yeah.
The digital processing cost, like keeping all the CPU running and the front end of the radio, the DSP for the radio, consumes much more electricity than the electricity that the radio transmitter uses. So the power amplifier that the radio transmitter gets used every time you transmit a package, 60 or 70 milliwatts. Now the rest of the chip consumes 300 by itself. So your base consumption is about 300, and then if you keep transmitting all the time, it goes up to 400. If you don't transmit at all, it's closer to 300, but it doesn't make such a big difference.
Yeah, but the Wi-Fi chip cannot access the flash memory. Then you need to, for example,
the Wi-Fi chip cannot access the flash memory. You have to wait. The flash memory is the file system is controlled by the geode, by the main CPU.
Yeah. All right. And how about the main CPU? Is that does that vary in amount of consumption, or is it always the same?
Yes, no, it varies anywhere between 0.9 watts to 4 watts.
Yeah. If you play video, then it's maybe maximum, or
if you play video, is maximum.
Yeah. But if you just
if you do nothing, it's about 1 watt.
1 watt. Could you just show a little bit the interface, different software?